Hi there. What I plan on hitting on in this movie is L'Hopital rule, and we're just going to focus on the product form right now. So, this is kind of an ambiguous topic, but I think you'll find that having this in your arsenal of little tricks, you might be less, I guess, intimidated by more complicated subjects later on. So, what if we have the product form? And remember, the product form will look like as x goes to whatever, a, and the form will look something like f of x times g of x. So what if we have this form? Well, basically what you need to do is you need to switch f of x, g of x, you need to switch this to quotient. That's usually what I recommend. There are tabulated ways of determining which one is better, but I feel like you're kind of taking a certain amount of the intuition, you're trying to take some of the thought process away by doing that, so I don't recommend doing that. What I recommend doing is switching this form, fx times g of x, to a quotient form, and that will typically look like this. You have fx, g of x, right? And you want to switch this to either f of x divided by 1 over g of x, or the other way around, g of x 1 over f of x. And a lot of people go, okay, well, knowing that I got to do that, which one do I do? And my answer is, do the one that works. Because a lot of the time, there isn't one that works. And once you get enough intuition about it, you'll actually figure out that some ways, well, both ways could work. One might solve itself out much quicker. So, but you'll get that feeling later. So let's just walk through a couple examples of the topic. And by the way, some people wonder, okay, what does an indeterminate product form look like? And that, I'm going to say, basically it looks like this. Indeterminate product form. Product form would look like 0 times maybe infinity. That's the only one I can think of, really. Yeah, because you can't really, you're thinking, okay, well, infinity times anything is infinity, but then 0 times anything is 0, so it's kind of like an ambiguous, like, well, what do I do? So, to solve these, you just need to have this kind of form so that you can turn it back. This is kind of an indicator of whether or not you can actually turn it back into a proper form of the quotient rule. So, let's walk through some examples quickly. Okay, so let's do, you have limit of x going to 0. Okay, let's do this one, x ln of x. And you're going, okay, well, how do I know that works? Well, if you toss x, as x goes to 0, we know that x will go to 0. So this portion right here will go to 0. But ln of 0 is actually infinity. We don't know if it's plus or minus infinity because it depends what side you're coming from, but just look at this as a negative infinity. It doesn't matter though, just understand this goes on forever. That's all you need to know. So we do have that form, but we should also just kind of like see if we can find it when we change it into quotient form. So what I'm going to suggest we do is we toss the x on the bottom. And the reason I do that is because when I have 1 over x, then you can see that if x is going to 0, you're going to have infinity on both top and bottom. You can kind of see that. If you can't, I can just work it out for you right now. Ln of infinity, that goes to an infinity. Negative or positive, doesn't matter. It's just a check. And 1 over x, if you have 1 over infinity, or sorry, 1 over 0, sorry, then that equals infinity. Infinity over infinity. So realize that we can do, both of these are valid checks on L'Hopital. So, okay. So let's just run through this. Write this down real quick. We'll have the limit as x goes to 0. You'll have ln x all over 1 over x. And we take the derivative of both of those. Well, we know that the derivative, I'm just going to write it out, but we know that the derivative of the top is going to be 1 over x. But what's the derivative of the bottom? Well, the derivative of the bottom is, this is like x to the negative 1. So taking the derivative of that, you're actually going to end up getting about negative x to the negative 2, which is going to look something like negative 1 over x squared. So negative 1 over x squared. There we are. So now, when we kind of simplify what's inside of these parentheses right here, you'll have limit as x goes to 0, negative x. Alright, so then, what if x goes to 0? Well, it's going to go to 0. That's simply it. So, that's our solution. Not too bad, huh? Just a little tricky in the head. Not so much on paper, but just tricky getting the concept. So, let's look at another one real quick. As x goes to infinity, let's say, 1 over x e to the x. There we are. Well, realize that this is still the same form, f of x, g of x. So, what is f of x? Well, let's just look at f of x as 1 over x, which, if x is infinity, that's 1 over infinity, which is 0. And then you have g of x, which is just e of x, which e infinity is infinity. So we do have that indeterminate form for products. And so now I like to bring it back to quotient form. I think it's the best way to go. So, I mean, f of x, g of x. Let's turn it into f of x, 1 over g of x, which is just going to be simply 1 over, we have 1 over x for f of x, right? So 1 over e of x. Well, I just wanted to point this out, that you can see that if we were to simplify this form, this is the quotient form, so if we were to say limit as x goes to infinity, and we simplified this, what we would have is we would have e of x over x, which I want you to realize that is infinity over infinity. It's the same thing as infinity over infinity, which also merits the L'Hopital rule. So I was just trying to show you that you can do checks and balances on your own work as well. So let's do a quick, finish this up. d over dx of the top, which is ex, d over dx, the bottom, which is x. This is going to equal e of x, this is going to equal 1. So then you just have, combine these together, you'll have limit as x goes to infinity. You're going to have e of x, simply, which as that goes to infinity is going to equal infinity. So this term will continue to go to infinity. It's not stable in any sense of the word. But that is our solution nonetheless. And I'm just going to follow up on some other topics in the next video. Have a good one.